This is the video 9 of MEKG video series. In this video, deck machinery topics are discussed. Topic 1: Chain Stopper.
Unlike that in B, sir, RPG, identical blanket, the Imperial variety of target. It's the next target is the Canada, with the T-root rank. It may be necessary that a full city dash speed.
Topic 2: Precaution.
Before carrying out any maintenance in a hydraulic system for windlass and mooring winch, stop the hydraulic pump if it is running. Switch off the electric circuit breaker and control room circuit breaker. Shut off the pump suction valves. Shut off the pump discharge. Shut off the return line valves. If required, drain the oil from the system. Display Men at Work warning board.
Topic 3: Anchor Cable Assembly.
Anchor buoy is fastened to the anchor and is used to indicate the position of the ship's anchor when on the ground. This helps in locating the anchor when it breaks loose from the cable. In addition, it alerts the other ships looking to anchor in the vicinity of the ship that it is already anchored. A space in the forward part of the ship, typically beneath the bow and in front of the foremost collision bulkhead, contains the anchor chain when the anchor is secured for sea. The end of the anchor cable, in other words, the bitter end, is connected to the ship's structure by means of a strong steel pin that remains inside the chain locker. Devil's Claw is an additional securing for the chain. Conventionally, this consists of a turnbuckle, usually attached at the base of the anchor windlass. The other end is taken inside the shackle of the anchor cable and then locked by pulling the end towards the windlass. Gypsy is the vertical wheel on the windlass over which the anchor cable passes. The hawse pipes are constructed on either side of the bow, with an anchor stowed on each side. Spurling pipes are the pipes leading from the base of the windlass into the chain locker.
Topic 4: Hydraulic System for Windlass and Mooring Winch.
The hydraulic system for windlass and mooring, which consists of a reservoir tank that contains the hydraulic fluid. The fluid level is indicated by a level gauge and the temperature by a thermometer. A pump circulates the hydraulic fluid and it is driven by an electric motor at a constant speed. The pump draws suction from the reservoir through the suction filter. This filter prevents random entry of foreign particles into the system. The hydraulic fluid gains pressure energy in the pump. A pressure filter, located at the pump outlet, prevents entry of contaminants generated in the pump into valves and cylinders. The pressurized fluid passes through the discharge filter, where fine sediments are removed from the fluid. The filtered high-pressure fluid passes through the cooler, where the heat is dissipated. Then, it passes through a control valve, which controls the fluid flow to hydraulic motor. High-pressure hydraulic fluid drives a hydraulic motor. This motor converts the pressure energy of the hydraulic fluid into rotary mechanical force. Fluid from the hydraulic motor returns to the reservoir through the return line filter that reduces the amount of dirt generated. When the winch is not in use, the fluid passes through the control valve, bypasses the hydraulic motor, and returns to the reservoir. Thus, the fluid is circulated through the system even if hydraulic motor is not in operation. The hydraulic fluid in the pipelines to and from the motor always flows in the same direction.